In this video, we're going to be using the approach in Gauss's problem, so Gauss's approach, to find the sum of arithmetic sequences. So let's take a look at this first one. We've got 1 plus 2 plus 3 plus 4 plus, and it goes all the way to 97. Okay, so we can see that it's going up by 1. So the approach to these problems when you're finding sum is twofold. The first thing you need to do is find the number of terms. Find the number of terms. Okay. After you find the number of terms, then you can find the sum of all these. So what we're going to do to find the number of terms, we're going to use this formula, which is T sub n is equal to A plus n minus 1 times D. Okay, so here's what these things represent. This is your last term. This is your first term. This is your number of terms, which we don't have. That's what we're going to try to figure out. And then this is what we call the common difference. Okay, the common difference is the difference between one term and the very next term next to it. Okay, so how much did it change by? All right, so we know most of this information in this problem. We know the last term, that's 97. We know the first term, that's 1. We do not know the number of terms. That's what we want to find. The common difference, how much are they increasing or decreasing each time? The common difference seems to be 1. Okay, so I'm going to write this formula down, but now I'm going to input the correct numbers. So for T sub n, I'm going to write 97. Okay, equals the first term, which is 1, plus n minus 1 stays how it is for now. And the common difference is 1. Okay, so let's go ahead and distribute the 1, or we really don't need to, but if this was any other number than a 1, we would need to distribute it there. On the next example, we will. On this one, we can just drop it. So it'll be 97 equals 1 plus n minus 1. Okay, notice that the 1 and the negative 1 cancel, so we get 97 equals n, and now we know that there are 97 terms. 97 terms in this problem. Okay. Now that we found the number of terms in the problem, now we can sum. So let's call this S. S is equal to the sum of 1 plus 2 plus 3 plus 4 plus all the way to 97. Okay. What we're going to do is look at that and pair off the first and last, and then the second, and then the second to last, and so on. So let me write down a few of these terms to show you what I mean. Plus 3 plus 4 plus, and instead of just writing the 97, I'm going to write a few more. So let's say we have 94 plus 95 plus 96 plus 97. Now this is still this right here. Oops. This is still this right here. I just wrote a couple more terms. But notice that what happens if I pair the first term with the last term. If I pair those together, what do I get as the sum? 98. Okay, what would happen if I paired the second term and the second to last term? What do I get? Also get 98. And you can see that this pattern continues. 3 and 95 give you 98. 4 and 94 give you 98. So all these pairs give you 98. Okay. So if I wanted to write this in terms of S, I could say S is equal to, now stay with me here, 98 plus 98 plus 98 plus dot 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 plus 98. But is that correct? Is this right? Well, it's not, because if you're pairing them together, there should only be half the number of terms, right? So what you would need to do is say, well, this actually only has half the number of terms in S, so let's go ahead and double it. Okay, this is maybe the most important part of this step. So when you pair them and you write it like this many terms, because this has the same number of terms as this, but they're all 98s instead of all these different numbers. Okay, so we write 2s to get the actual sum of the 98s plus the 98s. Okay, this is going to be the case in every one. So you're going to pair the first and the last like this, and then you're going to say 2s is equal to these. whatever these pairs are. And there should be the same number of terms in both of these. There should be 97 terms. The reason that's helpful is because of this. Now I can say that 2s is equal to 98. How many 98s do I have in this problem? Well, if it's the same number of terms as this, we already found that. There's 97 terms. So if there's 97 terms in this, there's 97 terms in this. So I can say, how many 98s do I have? Well, I have 97 of them. So this sum right here would be 98 times 97. Okay, so if I want to get the sum of s, not 2s, what I do here is divide by 2 on both sides. Okay, and that will give me s. And if you multiply this all out, I'll do it once this time. You'll have to do some of the calculating yourself for time's sake, but I'll do it once. 98 times 97 divided by 2, and we get 4,753. Okay, so S is equal to 4,753. The sum of 1 plus 2 plus 3 plus 4 plus ... all the way to 97 is this number. Okay, let's look at another example. Okay, I'm going to go through this one a little bit quicker. We've got 1 plus 3 plus 5 plus 7 all the way to 1,005. Okay, so first let's use our little formula, or I'll call this S. Let's use our little formula, T of n, which is the last term, equals A plus n minus 1 times D. Okay, last term, first term, number of terms, the common difference. Okay, so here's the last term, here's the first term. How much is the common difference? Let's see, how much do you go up between 1 and 3? 2. So 2 is the common difference here. So what we will get is 1,005 equals the first term, so 1 plus n minus 1 times the common difference, which is 2. Okay, so let's distribute that. 1,005 is equal to 1 plus, we distribute here, and we get 2n minus 2. Okay, let's combine this 1 and this negative 2, so that gives me 1,005 is equal to 2n minus 1. Okay, I'm going to add the 1 to both sides here, so that'll give me 1,006 on the left equals 2n, and then if I divide the 2, that gives me 503. So I have 503 terms. Okay, now we're going to do the exact same thing that we just did a second ago. We're going to pair these things up. Okay, so let's look at the first and the last and bring them together. So 1 plus 1,005 is 1,006. Okay, so that's what all of our pairs are going to be. If you did the next one, 3 plus 1,002 or 1,003 would be 1,006. So our pairs are equal to 1,006. So 2s is equal to 1,006 plus 1,006 plus 1,006 plus ... plus 1,006. Okay, and how many of those terms do we have? Well, we have the same number of terms as this. That's the same trick we did last time, right? So there's 503 terms. So 2s is equal to 1,006, and how many times does that happen? 503. Okay, and then if I divide the 2 on both sides, there, I get s is equal to, let's see, that will be s is equal to 253,009. There we go. Okay, you can put that in your calculator to confirm. Let's look at the next problem. Okay, for this one, we have 4 plus 9 plus 14 plus, see, they're going up by 5, right? Add 5, you get this. Add 5, you get this. Okay, so that's our common difference. D is equal to 5. Our formula to figure out the number of terms, T of n is equal to A plus n minus 1 times D. Last term, first term, common difference. Okay, last term 509. First term 4. N minus 1, we don't know the number of terms, so we leave n alone. And the common difference, it goes up by 5 each time. There we go. Okay, so 509 equals 4 plus distribute, and you get 5n minus 5. Combine the 4 and the negative 5, so you get 509 is equal to 5n minus 1. That's the 4 minus the 5. That's negative 1, right? If we add the 1 to both sides, you get 510 equals 5n, And if I divide the 5 on both sides, that will give me 102. So 102 is the number of terms. That's how many terms we have. Okay, so let's go do this one. So this we'll call S. So 2S will be the pairs. So what are the pairs? First and last term add up to 513. So the pairs will be 513 plus 513 plus dot 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 plus 513. How many terms are there? The same number as this, right? Okay, and that is 102. So 2S is equal to 513. How many times did that happen? 102. Okay, and if I divide the 2 on both sides, I get S is equal to 52,326. Okay, last example here. So we've got 872 plus 863 plus 854 all the way down to 8. Okay, so what's our common difference? This time it's going down, right? The common difference is going to be a negative number because it's going down. So 872 to 863, how much did it take to get from this number to this number? Negative 9. So if we subtract 9, we get here, subtract 9, keep going, okay? Okay, so here's our formula to find the number of terms. T of n is equal to a plus n minus 1 times d. Last term, first term, common difference. So last term is 8 equals first term, which is 872. Okay, and then we have n, whoops, I need a plus sign there, plus n minus 1 times our common difference, which we said was negative 9. Let's distribute this negative 9 here. So I get 8 is equal to 872. Let's see, negative 9 times n is negative 9n. And then negative 9 times negative 1 is 9. Negative times a negative. Let's add the 872 and the 9. So I get 8 is equal to, let's see, what would that be? 881 minus 9n. Okay, now I need to move this over, so I need to subtract 881 from both sides, and that will give me negative 873 is equal to negative 9n. Okay, and then if I divide that negative 9, that will give me n is equal to 97. So we have 97 terms. Okay, so now we label this as S, okay, and we pair them off. So what would the pairs be? Let's see, here's the first and last term. Add those together, you get 880. So that's going to be our pairs. 880 plus 880 plus dot 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 plus 880. Okay, how many terms does this have? It has the same number as this, which is 97. Oh, this is 2S, by the way. Sorry, 2S, because we're pairing there. So you have 2S is equal to 880, and it happens 97 times. And divide this 2 on both sides, and you get S is equal to 42,680. And that is the sum of this. And that's it.